All right, hey, in this video we're going to be looking at how to simplify our expressions by combining like terms. And I'm actually going to just open up this slides deck. These slides are going to go with everything that you guys see in your notes. So just be filling along with me as I'm going through on the slide deck. Okay, the slide deck is just slightly more interactive. So we're going to get started here with some vocabulary. And in the first two blanks, which you guys have, is a spot to write the words coefficient and constant. So you guys know at this point a coefficient is a number that multiplies a variable, while a constant is a number that's all by itself. And that number that's all by itself could be a positive or a negative number. Now in your notes, I've got some algebraic expressions. And the first one that I have listed there is the 4a minus 3b plus 2. This is an algebraic expression because we have both numbers and letters. So I've got it color coded here off to the side to kind of help it stand out, and you guys can just fill in right here in your notes. So the coefficients, the numbers that are multiplying our variables, are this 4 and then this negative 3. The number that's all by itself is the orange 2. It is a positive number, so we have a positive constant here. And the variables are the letters A and B. So the number being multiplied by A is a 4. The number being multiplied by this b is this negative 3. So again, the coefficients are 4 and negative 3. Now there's another example right there in your notes. We have this negative 8 plus 5x squared. So the coefficient, again by definition, a number that multiplies a variable, is this red 5. The constant is this orange negative 8. The variable is this yellow x. And this time, to define the 2, it's called an exponent. Okay? So now we have every single part of the algebraic expression labeled, and it's got a vocab word with it. And now there's another example in your notes. We have the 2n plus 11 minus 6m. And you guys can see here the coefficients again are in red. We've got a 2 times the n and a negative 6 times the letter m. So 2 and negative 6 are the coefficients. The constant, the number all by itself, is the 11. And the variables, we have two of them. We have n and m. So this is just getting comfortable with some vocab. Now below those examples, you guys see this right here, and there's two lines up above this to call this thing a numerical expression. So make sure you jot down that this thing is called a numerical expression. Put that in your notes. Now in this numerical expression here, I don't know about you guys, but I see two negative numbers. I see a negative 12 and a negative 4. And I see a positive 6 and a positive 11. Now all of these are terms that are numbers by themselves, so each term here can be called a constant. This is a numerical expression with 4 constants. There is a place in your notes for you to fill in the word constant, so make sure you've got that. Now when I see numbers like this, I like to group together my negatives and get 16 negatives, and then here I like to group together my positives and get 17 positives. And then you've got negative 16 plus 17, and that's of course a positive 1. So when you guys just do the adding and subtracting of just regular positive and negative numbers, which is for you, this is a 6th grade problem, you're actually combining like terms, which is the topic for today. You've put the negatives together, you've put the positives together, and then you just answered the last part here. So we have kind of already seen a little bit with combining like terms, okay? And that's what that's saying right there. We just simplified a numerical expression by combining like terms. Again, the green terms here were like because they were negative, and these white and orange ones here were positive. So a typical question is, like in algebra, you might see something like simplify 2a plus 3b plus 3a, okay? Now what I've got here is just a visual representation, which is, again, in your notes right in front of you. And you can see here that we have 2 apples, we have 3 bananas, and then 3 more apples. So if we think of A as being apples and B being bananas, I can use this expression to represent the fruit. And you guys can group together here, these 2 apples can group together with these 3 apples, and we can say that we've got 5 apples and 3 bananas. So the goal of this unit is to lump together the stuff that we can lump together. And sorry that that got like kind of messed up down there, but you can see that that's going to be a 5a plus 3b for the 5 apples and 3 bananas. Okay, there we go. One other thing I want to mention real quick is that there are 1, 2, 3 terms overall in the expression, and we shrink that down to the 2 terms. So again, we're combining the stuff that we can group together to kind of shrink this expression down. And there is the 2 terms in the answer. All right, so here's another picture for you guys. What if we had these 3 bananas, these 3 apples, some more bananas, and another apple? Now in the language of algebra, it's going to look like this. You'd see a 3b plus 3a plus 3 more bananas. And anytime you see something all by itself, it's just considered 1. There's like 1 of that letter. So if we go after the grouping, we can put the 4 apples and then the 6 bananas together. And we've now taken the 1, 2, 3, 4 terms and shrunk it down to 2. Now you guys know in your English classes, the boring stuff, you're learning about all these grammar rules. And in math, we kind of have some math grammar. So a couple rules to follow. We always put our answers in alphabetical order. So see how here we have 2 different variables. Anytime you have different letters, just put them in alphabetical order. And if you have a constant, the constant will always go last. Now in this example, we don't have any constants. I don't have any numbers all by themselves. But if we had like a +5, it would be the last thing that's written right here. Now also in your notes, you'll see at the bottom there of the page, you'll see this image. And we can also subtract like terms. So suppose that you bought 5 apples and then you had 6 bananas, but you ate 2 of your bananas. So again, here's what it looks like in the language of algebra. You've got your 5a plus 6b, now just minus 2b. Now you're not going to do anything with those apples. Those are going to stay in your answer. But if you have 6 bananas and take away 2, you'd get 4. So that's where I'm going to get that for the answer. So we have the 5 apples plus now 4 bananas. So when we're combining like terms, you can see that A's would go with A's, B's would go with B's. Okay? Now this next part right here, there's this video, and I'm actually going to, I know this is going to seem a little bit weird, but instead of just playing the video in my video, I'm going to have you just pause this YouTube video now, and linked in Schoology, I have this. It's going to be called like the Mad TV link. So just pause my video and then go back over and you just open up this YouTube video, this other YouTube video, and then just watch it. It's meant to be funny. It's meant to be a funny thing. And then when you're done with that YouTube video, just come right back on over to me and hit play. And I'm going to keep right on going in this video. Okay, so pause me now and go watch this other YouTube video. All right, so you probably did not make it through the whole thing. I'd be surprised if you did watch the whole video because partway through it gets like a little bit annoying that the order keeps going on and on and on and on. And I think that that kind of like proved the point that I wanted it to prove. So hopefully you watched that video. Like I said, if you didn't, it's okay. And I'm going to skip ahead now to join you guys. This is not actually anywhere in your packet. I just want to follow up a little bit from the video that you hopefully just watched. Again, this part is not in your packet. But think about if 2 people were to go out to eat, okay? And 1 person ordered this and 1 person ordered this. Let's talk about what might happen on the receipt when they get the receipt, okay? So in the language of algebra, I see 2 burgers, I see an order of fries, and I see a drink. Okay, so 2 burgers, an order of fries, and a drink. Now over here, I see 3 burgers, 2 fries, and 2 drinks. And y'all know some people get real hungry when they go out to eat. And most places will give you a free refill on the soda, so you might not see this in real life. But we might see some people who do this. I know some high school kids after some sports games who might order this if they were to go out to eat. But let's say we're trying to put these 2 orders together, like if you're making, if like on the receipt. So we have 1, 2, 3, 4, 5 burgers, and let me move that for the picture. There we go. There's the 5 burgers. Okay, so 2 burgers plus 3 burgers is my 5 burgers. We've got 1 order of fries plus 2 more, so that's going to be 3 orders of fries. And I see 1, 2, 3 drinks. So when we're combining that, the final answer would be 5B plus 3F plus 3D. Now you should be able to point out something that's wrong right here. What's wrong is that it's not in alphabetical order. So the only thing I would need to do is make it 5b plus 3d plus 3f, and then we'd be set. So this example is nowhere in your packet. There's nothing here in your notes, but I did just kind of want to follow up from that video that you just watched to kind of see just like another example of combining together burgers and fries and sodas. All right. Another thing that's not in your notes, but I just want to point it out, that a PlayStation 2 and a PlayStation 3, for example, are two totally different gaming systems. So if you see p cubed, it's very different than seeing a p squared. We're going to talk about that with like terms on the next slide. So now if you flip over, you should be at the top of the next page. This is in your notes. We are back in the packet. You will see this in your packet. So make sure you flipped over now. And at the top, we just want to get comfortable with some like terms. Now over here off to the side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different things going on over here, 10 different terms. Now first, I want to focus on the stuff that I can combine with a 5J. So basically, if I had, let's say the letter J here, like this is so random, but let's say it stands for jalapenos, okay? Let's say you have 5 jalapenos. Now let's come over in here and find any other thing that would just be a number of jalapenos. So the 2J, for example, you could say I've got 5 J's plus 2 J's, that's 7 J's. I could add another J and have 8 J's. And then we could even take away these 6 J's. And so anything that just has a J is going to be a term that can get combined with 5J. Now for that part, I'm actually going to come out of the slides here and I'm going to click and drag just so you guys, just so you guys can see what you should be putting in your notes. You should have the 2J written there. You should have J written there, if this wants to move over, and a negative 6J. Okay? If we group all this together, the 5J's plus 2J's was 7. This is an 8. And then 8 minus 6, overall, that'd be 2J's total. Okay? Now, for the next one, we have a J cubed. So anything else that has a J cubed can get combined. I already have one of them in this box. Now I have this negative 4J cubed, and I have a 10J cubed. So if you guys saw one of them, and then these 10 of them, that's 11J cubes. Now those 11 minus the 4, I have 7J cubes left over at the end of this. Now anything that's in here with a J squared, like these for example, these could get grouped together. And you might see this, I'm just going to put off to the side just so you guys could see what you might have in my math class as a problem. You might see the expression 8J squared plus J squared minus 3J squared. And you can simplify that. 8 of them plus 1 of them is 9 of them. And then 9 minus the 3, we'd have 6J squareds. So you would just tell me at the end of all of that that you have 6J squareds. And let me just fix that formatting here. And I'm going to tell that to be an exponent. Cool. So you see what you're doing here? The 8 plus the 1 is 9J squareds, and 9 minus the 3, that'd be 6J squareds total. All right. So we can combine with just a J. We could combine with J cubed. We can combine J squareds. Now this JK, there's nothing I combine with it. And there's nothing I combine with this. These are all independent by themselves. There's nothing that we can combine with those. Okay. Now it's that you can ignore right there. I took away the color coding. All right, sweet. So now I'm actually going to go back into presentation mode. And let's go through these next ones. Again, we are in your notes. We are in the packet. So now let's go through and decide if the pair of terms that we have, if they are alike or not. So let's say G stands for grapes, and what would H stand for? Maybe like pieces of ham. So if you have 4 grapes and 4 pieces of ham, Well, then great. You have 4 grapes and 4 pieces of ham. You can't lump those together. So no, these wouldn't be like terms because they have different variables. Okay, I wouldn't put that together and say 8GH. Nope, 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 nope. They are not like terms, so I can't do anything with them. Now, if you have 3 H's and you want to take away an H, you sure could do that. 3H take away an H would be 2 H's. Now, if you had 5 X's, but then 4 XY's, there's nothing you can do there because you have different variables. Now for this one, the 2x squared y cubed, and then we have 2x squared y to the 5th. We can't combine that because we have different exponents. So let me go back up here now to the definition. It's when you have the same variable raised to the same power. So for this next one, see the p squared and then q cubed, p squared q cubed. Now you have the variable raised to the same exponent, and this we could combine. We could take 5 of these and minus the 4 of them and just have 1 p squared q cubed. Okay? So hopefully you've got this part written down in your notes. And friendly reminder down for that last one, that if the coefficient's ever a 1, you don't ever have to write it. You might remember that from even the slope unit. So anytime you have a 1, you don't need to write that. All right, we are still in your notes. So now let's just simplify this expression. If you saw 4w plus 3 plus 2w minus 1, the 4w and the 2w go together to make a 6w. The 3 minus 1 is 2. 3 minus 1 is 2. So that would be the simplified expression. It went from 1, 2, 3, 4 terms down to just the 2 terms. All right. So now for this one, we've got 2a cubed minus 10ab squared plus 3a cubed minus an ab squared minus a 7. We've got a lot going on here. First thing I'm going to point out is that we've got 5 different terms. 1, 2, 3, 4, 5. This one is an a with a cube. So is this one an a with a cube. I have an ab squared and another ab squared here. And here I have a number all by itself, so that's going to be a constant. So we have 5 terms. The 2a cubed plus 3a cubed is where I'm going to get my 5a cubed. If I have a negative 10 of something and I take away one more of them, I have a minus 11 ab squareds. And there's nothing to combine with that negative 7. So we have 3 terms in my final answer. Now here we have some things to remember. The answers always go in alphabetical order, which we already talked about. If you have exponents, I don't think we mentioned this yet on the last slide. If you have any exponents, the exponents go from highest to lowest. Notice here that anything that had the cubed went first, then the exponent that was a 2 came next. So if you have different exponents in your expression, you order it from highest to lowest. And then look at the example I have down at the very bottom of this slide, y'all. So do you see how I have exponents and I have different letters? Notice that the M comes before anything with N, so alphabetical order always wins. So M, anything with M, and then N. So the M all by itself, the M transitioning with N, and then N comes afterwards. M squared, MN, and then anything with the letter N comes at the end here. And even though this exponent is higher than these other 2, I want to point out that the alphabetical order is what's always going to win over the exponential order. Okay? Now here we have one final problem. And if you want to pause the video and just answer these questions, feel free. I would say at this point you should be able to answer all 4 of these questions. So if you want to pause it, go ahead. All right, so in these, we've got 1, 2, 3, 4 expressions to start out. Or sorry, 4 terms, 4 terms in the expression to start out. Now our coefficients here, we've got a 53 in front of the t. Be really careful about what you tell me is in front of the R. Remember, y'all, anytime you see a double negative, like minus a negative is really adding. So this is really like saying plus 20R. So that's why I have a 20 right here, not a negative 20. And then the number that's in front of this T over here is a negative 10. So those are the coefficients. We do have one constant. It's the number 17. And which of the following, or sorry, not which of the following, what is the simplified version of the expression above? So the plus 20R, there's nothing that can go with that. Now I can take these 53 T's and minus 10 T's and get 43 T's. And then there's nothing I can do with that constant. Notice my answer is in alphabetical order, and the constant is written last. And that takes care of this question. Now again, in those things to remember, if you haven't already written that down, that the answers are always in alphabetical order. Alphabetical order will always win. And if you have any exponents, remember to order them from highest to lowest. We don't have any here, but I just wanted to remind you of that. And in this problem, we had to rewrite the double negative from the very beginning. That minus the negative was really a plus 20R. Now there is this game for you guys to play. It's going to be in the slides that I post for you all. And in the slides, you're going to actually just tell me what level you got to in the game. So like in your independent slides, which is over here, this is the student copy. When you click right here, that takes you to the game. And just play until you like kind of level out or don't have any more lives left over. And then just right here, type in and tell me what level you got to. And then in the slides, there's this question. There's clicking and dragging here and clicking and dragging here to match. And then after that, you'll have a check for understanding. And that concludes the video on how to combine like terms. If you want to double check that you got your packet filled out, like I said, everything that I showed you guys in the video does match up with here in your notes. I just had it in the slides. So again, if you need to look back anywhere here and pause the video to make sure you've got all that filled out, but you should be good to go. Thank you for watching.